knowledge about SQL. So for SQL, we first learn some SQL queries, and later we learned transaction, right? It is a very important concept. And also we covered ACID of the transaction, what are each of them stands for. And later we learned the index, right? And also we learned execution plan. And we learned how to, based on the execution plan, maybe to change, to give hints or change queries, use different queries for the, maybe for the same effect, or the same effect, we can use different queries to perform it. And maybe those different queries will have different execution plan for the same result, but the performance of them maybe varies. And also we learned, let me think, what we learned, like index, execution plan, hints, and oh, table design, right? Table design, normalization, things like that. So, so we learn like primary key, foreign key, things like those concepts, composite key, and those are for SQL database, and we know that it's good for not suit for horizontal scaling. We learn what is scaling, right? Not maybe suit for vertical scaling. And those things are for SQL part. And for today, we learned something like NoSQL. We know that most of the NoSQL are distributed system. And for distributed system, we have like different hash mechanism. And also we learned MongoDB is CP, right? We learned Capserium. And we learned we can only choose two of them to achieve. And MongoDB is CP, and Cassandra is AP. And the Redis is in-memory database. Like in the internet, they say that most of the implementation for the Redis, they just a single server. So it's kind of a CA, but I do not like CA. Like I think some of the articles says that there is no CA system, like because it's kind of meaningless to talk about CA. But yeah, just do not. Maybe there's not much articles to categorize like whether Redis is following what Capserium. But just to remember that we can use Redis as a global cache. So this is for NoSQL. And also one thing that NoSQL, you see, whether it is document based or column based, it does not have a flex. It is very flexible, right? It does not have a fixed schema. Flexible, no fixed schema. But for the SQL, you have to define your table, define table. You have to do the table design. And yep, I think that's quite what we have in this week. And So let me first ask a question that suppose this question is for SQL. Like suppose you have a SQL database. You see, in the first 3 days we learned SQL. If a SQL database have a query slow and does not have like maybe it does not have enough space, like not enough space. So what you can do to tune your SQL database? Storage. Like, do you have any idea to tune your database, SQL database, relational database? DBMS. Question is, like, suppose you have a slow query and do not have enough storage space. What you will do to speed up your query performance, the performance of your SQL database? Yeah, yeah. You can look at the execution plan and consider about the normalization, using the normalization to save some storage. But there is also maybe like first you can check execution plan. Also, for normalization, normalization can save normalization to reduce redundancy. But you know, when you normalize your table, actually, if you have join operation, your performance will be slow if you normalize your table. If you have a lot of join operations, so it's like a trade-off. If you maybe you want to use the normalization to reduce the redundancy to increase some storage space, to save some storage space, but maybe you will use the normalization to speed up drawing queries. And also, any other idea, like the query slow? Imagine like we learned things like those things, and also remember the isolation levels, things like that. Any other idea? Use index. Yeah, we can use index. We can, after check the execution plan, we might know that there are we're doing a lot of full table scan. Then at that moment, you would know that maybe we'll need some index on some column. So, and vertical scaling to enlarge storage. Yeah, also, this is like, those things are like for the single node. And if you have, yeah, and maybe if you have a cluster, yeah, but SQL database generally they will not do horizontal scaling on SQL database. So yeah, maybe just vertical scaling those. That's a good point. Just vertical scaling the SQL database, so we can like either the CPU or memory or disk, things like that. Just vertical scaling the hardware, upgrade the hardware. Upgrade hardware. So also, like when we talk about the repeat request that you mentioned about the storage procedure, right? stored procedure is more like a function. So you can actually it can save some time, like because when you use the store procedure, when the first time you execute it, the database will cache the execution plan uh, for that stored procedure for that function. So whenever the next time you execute the same function, the same procedure, you can reuse the execution plan. It can save some time, but the plan are stored in the cache, right? So no matter like you store the execution plan or you use another cache to store the cache the data, this is also one way that you can use the cache to store some to store the previous result. So you can the next time you do not have to search in the disk. You can just search from the cache. You can speed up. You can just fetch the data in the cache rather than the disk in order to improve the performance, right? So you can either introduce a cache. Yep, and also like for the execution plan, you remember that we have a hint, right? If you think the SQL database optimizer is not very clever, you think the execution plan is wrong, I can give some hint to change the behavior, right? You can change from full table scan to index range scan, or you can change the index range scan to index unique scan, or change index unique scan to full table scan, things like that. You can change the hint. So yeah, and also maybe you can just change the query, like because different queries can have same result, but maybe the execution plan for those queries are different. So you can even change the implementation, the implementation for the queries in order to change the execution plan to find a more efficient execution plan and in order to improve the performance. Right, so those are some ways to improve the performance. I guess this is quite a lot. And yeah. And if you have any other idea, I think, but this is so far that I can come up with. I think those are the ways that we can speed up our queries and increase some storage space. Yep. And yep, I think that's it for this question. And let me give you guys another question. Like this is a really, really common scene question. Like what is the difference between SQL database and NoSQL database? So this question is really, really commonly seen. Like SQL, NoSQL. Any idea to this question? Like what is the difference between SQL and NoSQL? Yeah, flexibility. That is a good point. Like the first thing is the SQL database will have you have to predefine, you have to design the table, and it has a fixed table. So all the data should follow, when you insert records, they must have the same field, same columns. So it's not flexible. Once you define it, you cannot change it. But NoSQL database, there is no fixed schema. So it's a very significant difference between those two. There's no fixed schema. You just like you can just like document base, you just insert whatever document. Those documents might do not mandatorily to have the same field in the document. And also for Cassandra, like the column-based NoSQL database, they are not necessarily to have the same columns. So there's no fixed schema for NoSQL database. This is one of the most significant difference between SQL and NoSQL. And also other things like SQL had a better performance on vertical scaling. NoSQL, yeah, I think you can say that SQL yeah is fit for vertical scaling, but actually for NoSQL database you can do both. Like there is no harm that you upgrade the hardware, or you can just do the horizontal scaling. But NoSQL, yeah, but I think maybe because vertical scaling, I think it will be like cost more than horizontal scaling. So if you can have the choice, maybe you can just prefer the horizontal scaling over the vertical. But you can have both the choice. Maybe just based on the design, based on requirement. But maybe you will prefer horizontal over the vertical. But it's like some trade-off. Like whenever horizontal, it's maybe there is like you have to carefully design about the data data consistency, and also consider about the partition algorithm, partition strategy. So yeah, this is two difference, like the scaling difference. Like SQL is not fit for horizontal scaling, and also like any other idea? Like SQL queries use joins. NoSQL usually does not. Yeah, yeah. So SQL supports like the joins, things like that. But NoSQL basically poor support for join. Yeah. So NoSQL basically have poor support on join things. Like it will use something like the pre-join, like just to store all the information in one document. So when you perform the select, I think because join will time costly, and for NoSQL, because it just you store all the thing in one document. So it just although it not support the join, but I think you have better performance. You just like denormalize all the thing into one table. So yeah, that's one point. Good point. Any other things? Maybe you can think about the transaction. Oh yeah. So for this query performance, one thing you can tune is that you can set the isolation level, right? You can, if you think the query is slow, and maybe you can set lower isolation level, but it will harm the data integrity. But it based on your choice. So SQL feed transaction better because yeah, and actually NoSQL database, they generally do not support transaction, or in MongoDB there is called a lightweight transaction, or Cassandra. Let me try to find it. Lightweight transaction. So lightweight transaction. I think there is one. Let's see, let me put it here. Like there's something called lightweight transaction, but I think This lightweight transaction only is an insert operation that must be unique, such that this, although it's called a transaction, but does not have a bunch of queries. It just have let me think. Insert into, yeah. Those lightweight transaction is kind of a different thing, although it has the terminology of transaction, but actually maybe it just secure the consistency for this specific query in Cassandra, but it's not the same thing. Although it has the transaction, but it's not the same thing as the transaction in the SQL database. So it's just a like lightweight transaction. Yeah. So actually, you cannot find. Maybe they'll not have while support on the transaction. So Cassandra have something like lightweight transaction, but it's not the transaction in the same thing in the SQL. It does not. You remember that in transaction, the transaction in SQL is a bunch of query, and you treat those bunch of query to be one entity. Either they successful together or they just roll back together. So there's like no transaction, or maybe lightweight. You can, if you have interest, you can read about lightweight transaction, but it's kind of different thing. So when you mentioned about transaction, you can further talk about the ACID things, right? You can talk about the atomicity, consistency, and isolation level and durability in the SQL part, and what are those means, and also maybe it's not very appropriate to compare the ACID to NoSQL, but I think you can to compare the ACID with the CAP, maybe it's not very appropriate, but when you talk about NoSQL database, you can always mention about the CAP theorem. You can, because it's like a distributed system, and most of the SQL database is just a single node. So, or they will have some replica nodes, but basically those nodes will follow the transaction ACID. But for the NoSQL, you can mention about the CAP theorem, like how does the NoSQL database make choice for the consistency between the different nodes, and the availability choice, partition tolerance. You can talk about that. And for SQL database, you can just talk about the transaction properties, like the ACID, what is the atomicity, like how it treat all the queries as one entity, and what is consistency in SQL, like the stage, at least the default isolation level is read committed. So uncommitted dirty data is not readable by default. So its consistency is the database stage will just move from one valid stage to another valid stage. And also the isolation level, how you set your isolation level to tune the performance of a database. And this D is just save to disk, nothing special. Yep. And I think, yeah, I think basically those are all the things that I can come up with for now. Yeah. I think if you maybe sorry, at least answer the this most significant part, like a fixed table and no fixed schema, like the more flexible. And you mentioned about the transaction, ACID, and the CAP theorem. You mentioned about the scaling. I think it will be quite sufficient. those things like drawing or not, or the pre-drawing for NoSQL. Maybe you can you can mention you can also mention them. Yeah. Yeah. I think this is basically the answer for this question. The difference between SQL and NoSQL. And mm, yeah. And that's all for today's training session. And let me briefly go over all the things we learned in the first 2 weeks. Sorry, it's kind of slow. Mm. All right, here it is. So for day one, the most uh, important thing is OOP concept. Right? You have to know that what are the most uh, essential part in OOP, like a class is like a blueprint, and an object is the instance created from that blueprint, from that class. And also each class or instance, they will have their behavior, that is the method. And also they will have their characteristic, that is the attributes, like the data member inside each class associated with each instance or class. And like actually maybe at first you think the OOP is like a restriction, like make you feel hard to coding. But actually, once you get familiar with it, it will make much easier for you to get to learn new things. Like everything, when you touched something in Java, you just consider it as an object and think about, oh, what object it is and what behavior it has, what attributes it have. Like for example, if you want to interact with the Redis, you never touched Redis before. You will not have any idea like how can I use it. But with OOP, it's kind of easier. You will know that at least you will have a general idea, like think about that. Oh, if I want to use the Redis in my program, all that I need is just a Redis object, a Redis instance, maybe that provided by some library, by some package after you maybe use Maven to import it, and you can just directly use that object, and you will know that, oh, all that I need is to use some method or use some attributes in that object. So it's kind of, when you're familiar with this, it kind of makes you more easier to interact with or learn new things. Also, like when you try to interact with the database, maybe all you need to think, all the things you need is an object of database. And in this case, maybe the object will be an entity manager. So all you need is that I have an entity manager who will help me to manage the transaction with the database, and all that I need is to use the method from that um, entity manager, from that object. So it's kind of make your idea, make your thought to be clear, and when you use new things. And so and also when you talk about OOP, four things that you cannot pass by is the four principles, those four terminology, like what is polymorphism, what is runtime polymorphism, what is compile time polymorphism. I believe you guys should be, and also upcasting, those things I have already give like code examples for them. So I think it's quite clear what are those things means. And also the inheritance, we learned that we can use the extends or use the implement to inherit from the either interface or from a class or abstract class, then you can reuse those code. And also encapsulation, we learned that we can use the private keywords to choose that what attributes or what method, what behavior, what interface, like this interface is not the, maybe I change a word, like what method you want to exhibit to your user, what things you want your user to have access with, or what things you do not want. So this is called encapsulation, encapsulate those attributes inside your class. So abstraction, yeah, we learn interface, we learn abstract class, and we learn the difference. Also, we learn the new features introduced after Java 8 and Java 9. So those concepts you should be familiar with. And this is for OOP, like those examples just for illustration, but I think it's help you to understand what's actually going on. And for static, you should know what is static keywords for. Like the static, whenever you decorate any like code block or method or attributes with static, then that means this method attributes just directly belongs to the class object itself. Does not related to any specific instance or abstract object derived from this class. It just directly belongs to the class itself. So if you are trying to access this static attributes from no matter what instance, because it's allowed to access this attributes from the instance, right? Even though it's static, but you should know that you are even though from different instance, actually you're accessing the same static attributes because this attributes is directly belongs to the class itself, just that one class object. So this is static. And you should know that static means cannot inherit because it's meaningless to talk about inheritance when you decorate something with static. Remember, if you decorate it with static, it belongs to the class. So if you inherit this class in another in your subclass, then actually this you cannot inherit it if you have a same name, but that method attributes directly belongs to that child class, and the previously attributes with the same name just directly belongs to the parent class. There is no complicate, so there's meaningless to talk about inheritance, so it cannot be inherited. And also one important terminology is called Java is passed by value. So in some interviews, they will write some code and ask you that what is the expected output. And those are maybe some questions will be related to Java passed by value. Like they will write some like those change student method and ask you to predict the result. But this in the interview. I think in the evaluation, my supervisor won't ask those questions, but he will. I think my supervisor will only ask you about whether Java is passed by value or passed by reference, and you can just explain what is passed by value means. Like you see, every statement on the left part is the reference variable, and this part is the actually the new keywords invoke the constructor to construct an object. And whenever an object created, the object is stored in the heap, right? Like the stack is uniquely to each thread, but the heap is shared by all the threads, right? And also the object itself is inside the heap, and this constructor method will return the address value of the created object and assign that address value to your reference variable. So the left part is a reference variable of type student. And this reference variable actually stored the value of the address. So when you pass it to another reference variable, like maybe this reference variable is a method parameter, right? When you pass to it, it just pass the value of the address. So this is the meaning of Java passed by value. And if it is just a primitive type, like int I equals to 1, then For those primitive type, you just directly store the value. This primitive variable is just directly store the actual value 1 inside it, not like this. The student is an object type variable, right? So the reference variable will store the value of the address, but the primitive type directly store the value itself. But like, for example, if I have a wrapper class, and this actually, this integer I is an object that wrap the value inside it. So actually this is also a reference variable store the address value of this integer object. So this is Java pass by value. And also we learned final. You have to know what is final. Like if you decorate with variable, what will happen? Decorate with method, what will happen? Decorate with class, what will happen? That is final. And immutable, just to know several types of immutable in the Java. Like also you know what is immutable. Like once you instantiate this object, it can never change. Like if I have an immutable list, and that means once you created this list, then all the elements inside the list should not be various, should not be changed. And also for string, once you create a string object, the string object cannot be changed. Like if you do something like create a string equals to ABC, and then later in another statement you do str equals to BCA. Actually, you are creating a new string object assigned to the same reference variable, but actually you will not change this ABC string that created anymore. So the string object is immutable. And also for the wrapper class, like the integer or boolean or character, those things, wrapper class are also immutable. Like whenever you changed it just assign another address value, like another object address value to the reference variable. It not those things, once you create it, it cannot be changed. So those are immutable. And for day two, we learned exceptions. So you have to know what is checked exception, what is unchecked exception, the difference between those two. And arrows just some fatal issue that you should stop your application immediately, right? And you have to know how to resolve exception, whether to use throws keywords to throws to the upper layer, or just to use the try catch block to handle it by yourself. And also you learn finally, right? Finally is used with the try catch finally. No matter exception happens or not, the code block in the finally will always be executed. So this is finally. And later we learned array. Array has a fixed size. Once you define the size, you cannot change it. And it has a continuous memory allocation. That means once you know the head address of the array, you can just access the element by the index, like so same as access it of the offset. So you have the head address, just add the offset. You can use O1 time to access the data at the specific index you're trying to find. So it's array, and be cautious, like the difference about primitive type array, it will have a default value, but for object type, like the wrapper class integer, the initial value will just be null. Like there's no null in all the value in the array is just null value. And also this is quite important, like the difference between the array list and linked list. You see, array list eternally using array, so access time is O1. Access specific element, the access time complexity is O1. And for linked list is ON. And also, because array list eternally using an array, so when exists the limit of the eternal array, you have to resize it. The time complexity will be ON. You have to copy all the old thing and paste it into a new array, newly created array. And linked list, there is no such thing as resize. You just append a new node and modify the pointers. That is all. That's all for the linked list. And also continuous memory allocation. And also that's the reason why the access time is O1. And linked list because you are just creating a new node and link those nodes. So the nodes you created are randomly distributed in the heap. So, and also for insertion, deletion, like if you insert it in the middle, you have ON search time that is required, and O1 manipulates pointers O1 time. So if you insert at first or insert at last, at last, at first, at last, it will just have O1 operation time for linked list. And for array list, the insertion and deletion, if it's causing the resize, then it will be O1. Otherwise, if it is in the range of the internally array, then it's just O1. But if it needs a resize, so you see the resize time is ON because you have to copy paste all the things. And for hash map, this is very important. You see, this mechanism is very important. You have to know that's why we need hash code, why we need equals, and you know that there's an eternally node array in the hash map, and we will search through each bucket in the node array, right? Each node is one bucket, and it will either be a linked list node or be a red black tree node. And whenever we try to put something into the hash map, we have to first use the hash code and rehash to compute the index of the nodes. So we will know that which bucket we should go into. And when we go into the node, we have to find that maybe you don't have to go that detail. You just remember that when you use the hash code to go into the specific node, you will check whether the node is empty for now or not. So if it's empty, then means there is no hash collision. You just store the value inside it. But if you find that there is already a node, you will know that there is a hash collision. So you rather form a linked list, you loop through the linked list using the equals method to check whether the key is the actual key that you are trying to find, or you just you find it's a red black tree node, you just use the tree method of search in the binary search tree to find the target key. If you do not find it, you just insert a new node. If you find it, just modify the current existed node value. So this is the mechanism of hash map. It's quite important. Just be sure to over review it. And hash set, yeah, you have to be familiar with the difference between the list and the set. Like list have an order, right? And set, because eternally is a hash map. So we just use the hash value to compute the insert element to check which bucket it should go. So there's no insertion order be maintained in the hash set. And also list allows duplicate, but set does not allow duplicate. That is because set is eternally using a hash map. So the same element will be going to the same nodes, the same bucket, same nodes, right? So there's no allow duplicate. And tree map is actually just using a red black tree as an implementation. So for tree map, it's just a red black tree. It's just a binary search tree. Whenever you insert a key, you just follow the binary search tree order. So compare it. So there is the order. Like you can provide a comparator for the red black tree for the tree map to determine how to sort your key value pairs. So it will sort based on the key. So there's the order in the tree map, but it's not the insertion order, just the like you can sort your key by ascending order or descending order or some other rules. And then when you loop through the tree map, when you loop through your tree map, you will like have an order, like you follow the order of the key. So not the insertion order, but the order you provide by the comparator, like how you want to compare your keys. And also we learned iterator. So we learned concurrent modification exceptions, right? So yesterday when I support the interview, I met a question that they ask that they provide me like a code and ask me what is the expected output. So you will check that sometimes they will give you code like using a for loop. Inside for loop, they remove something for each loop. This is called for each loop that you see. It's not like for int I equals to blah blah and I plus plus. It's not like that for loop. It's a for each loop, like for each element in the list, like this syntax. This is called a for each loop. So in the for each loop, it's eternally using the iterator to loop through the list. So if you directly call list or remove, if you see such code, you will immediately figure out that, oh, this should give me the concurrent modification exception. You should know what is concurrent modification exception and how to resolve it. Like you can use the iterator to loop through it. Then because the iterators remove method will also modify the expected mode count by +1. So the expected mode count will be equals to the mode count when you remove it. So there will be no concurrent modification exception if you use such manner. So this is one of the iterator, just to learn the know how, like in which scenario the concurrent modification will happen and how to resolve it. Those are those kind of those things. And let me further talk about, I think that's all for the day 2, right? And day 3. Day 3 we learn Java memory model. So learn, you should know what is stack. Stack is last in first out, and what's stored in the stack. That is the local variables reference. So the address value, like address value pointing to the actual object is stored, the reference is stored in the stack. And also, maybe I forgot to mention one thing, like each thread will have it on stack. And the heap is shared by all threads. So, and also the object itself is stored in the heap. But when you create an object, the object is stored in the heap, but the reference variable will keep in the stack. And also the stack frame. I think the terminology I wrongly use it. Maybe not called method frame, it's called stack frame or something like that. So those frame will, whenever you invoke a method, it will create a frame and insert it in the thread stack, in the stack of that thread, and then it contains all the method parameters, local variables reference, like those reference variable, but actually the object is stored in the heap. You see. And also the heap also stores the class metadata, like how to build the class, and also the method execution code. Those common things will be stored in the maybe the like the method area, like in the heap. And also be familiar with such generations. Be familiar with the partitions of the architecture of the heap memory. So you know that there is Eden area, survivor area, old generation in the heap memory. You know that how heap divided those things, and be familiar with these things like this. Let me see, where is it? Oh, yeah, here. Be familiar with this flow. Like whenever an object is created, it will first create it in the Eden area, and after it survives several GC process, it will be promoted to the survivor area. And after like the survivor area have a mechanism like to after some GC, it will compact it, copy paste to survivor 1. And after some time, survivor 1 will compact data into survivor 0, but at the same time, only one of the survivor area is activated, other one is idled. And after the object survived in either survivor area, so both of the areas called survivor area. So once your object resident in the survivor area for a certain time, certain GC collections, certain time of GC collections, it will be further promoted to the old generation. And also, maybe if you can just remember some GC algorithm happens in different generations. But yeah, those things maybe not very important. And G1, if you know, that's good. If not, just maybe just not very important. But you know there is an algorithm called G1 that will be good. And also know that we cannot force GC running, right? This is one thing that they might ask in the interview. So we cannot force GC. We can only give suggestion. So this system.gc statement is just a suggestion, not a requirement. And also, there might be some question like what is final versus finally versus finalized. So the finalized is you override the finalize method in the object class, and whenever this object gets destroyed, it will invoke the finalized method. But this deprecate method is not recommended that you override the finalize method to give extra load for your GC algorithm, because if you override the finalize method, that means when the GC collect your garbage collection, collect your garbage collector, collect your object, it will perform for extra work. So it slow down your performance of your application. So you see there's a line through the finalized scores, means it's deprecated. So, and for the thread, you have to know how to create a new thread. There are two ways: one to extend the thread class or provide the runnable instance or things like that. Also, be familiar with the thread life cycle. Like when you create it, it's new stage, activate. Only when you start it, it activates. And you can make it sleep or make it wait, and learn the difference. You have to know the difference between sleep and wait. Wait will release the lock the current thread is holding. So also that's the reason why the wait can only be used in synchronize, or when you have a lock, when your current thread have a lock, you can only use wait in that scenario. Otherwise, it will give you error. And for sleep, sleep won't release lock. So if you in a synchronized block or in some place, if you, and also if you use the sleep in those scenario, it will sleep with the lock. Like it will not release the lock. Other thread cannot compete for the lock when you are asleep, because you're actually when you sleep, you're actually still holding the lock. And also you can call sleep either or not in when you hold a lock or not. So you can just sleep your thread even though you do not hold the lock. So this is the difference between sleep and wait. And also after the thread running, all of the things, all of the work is done, it will terminate itself, go to terminate stage. And the thread is one time using. Once it terminates, you cannot start it again. It's just gone. The thread is gone. You have to create a new thread and run. So also this one time using, create a thread is kind of expensive. So this is also the reason why we need a thread pool, that we want to reuse the thread, not to just waste our time creating thread. Oh, yeah, you have to know what is volatile, and volatile provide us. Please keep in mind that volatile provide us visibility. That means we directly read from memory, not from the cache. And also volatile provide M-fence. M-fence means it's a memory fence that avoid reordering the code before the volatile variable and after the volatile variable. It will keep the order and prevent the optimizer to reordering your code. So it will prevent reordering. So remember those 3 points for volatile. This concept is quite important. Just remember it. So maybe in the final evaluation, my supervisor will ask you what is volatile. So be sure about remember those 3 points. And other things, let me think. And also volatile itself, remember itself cannot secure thread safe, right? It should, if you want to achieve some thread safe, like resolve the race condition, you have to use volatile together with CAS, compare and set, to secure the thread safe. And this is race condition, like when you concurrently modify some data, you might lost those updates, and to resolve it, either using the lock, like the synchronize, to make the updates step to be critical. Otherwise, just use volatile plus CAS to do that. And yeah. So also one thing I want to mention is forgive my bad memory. I just forgot what I want to mention. I think something related to the water or synchronize. Oh, I just forgot it. What is it? Maybe let's just go to day 4. Maybe I can remember it later. So for the CAS and volatile, we can use them together to keep the thread safe, like to achieve an optimistic lock. To whenever you set it, you have to when you update it, you have to compare. You only update when it satisfies the condition, like the expected value equals to the current value. So this is compare and set. You should know what is compare and set. And blocking queue, just know what is blocking queue. That is enough. Like whenever the queue is full, you just block all the producer, and whenever the queue is empty, you block all the consumer. That's a blocking queue. The also disadvantage is for synchronize. Like it only has one waiting list, no fair lock, no try lock. With reentry lock, we can have all those. We can resolve all those. We can resolve all those disadvantages. And for deadlock, you should know what is deadlock. Like they are holding the lock that other threads are expecting for, and like circular dependency. So they will block each other forever. This is deadlock. The thread pool, like maybe for thread pool, like you have to know several types of thread pool and know how to create them. Like you know what is executor. Executor is a interface that provides you an execute method. You can assign a thread pool to this executor type reference variable, and later you can use the method from it to interact with your to submit a task, execute your task. And also executor service, also an interface that you can assign a thread pool to this type of reference variable, and this further provides you the submit method that you can submit a callable as well as the runnable. Like you can also submit a callable in order to get some return value. But with the executor, you can only provide runnable. You cannot get any return value. And yep, this is also you can use the executors. You see, there's an extra S. This S means you can use this library it provides you a lot of predefined, well-defined thread pool. You can just call executors.new cache thread pool, and then this method will returns you already defined cache thread pool, and you can later use this thread pool, like assign this thread pool to the executor service, then use it. So this is how you create what collections you can use to create thread pool and what kind of thread pool you have. Base thread pool, scatter thread pool, fork join pool, things like that. And this is basically for day 4. And for day 5, check. You see, day 5, we learn Java 8 new features. We know Java 8 has static default method for interface. Also, we learn what is functional interface. You have to know only contains one abstract method, and you should know the difference between runnable and callable. And also, you have to know lambda expression. Lambda expression is worked with functional interface to provide an object of that type of functional interface, right? You remember the flow, this give a created object from the anonymous class. The anonymous class is implement that type of functional interface, and also this anonymous class implement the abstract method in the functional interface like this. Also, we learned optional. You know, this the wrapper class. It provides you a lot of method to deal with the null value. The if you wrap this thing in the optional, then that means this thing might be optional. It can represent or cannot. It can be a null or not. Also, if you just use the null of method to create it, then it not allows you to provide a null value. It must be not null. But if you use the of nullable, you can provide a null to create the optional object. So just basically a replica deal with the null values, and for the null check, like resolve some null check. And for the stream API, we learned some intermediate method, and also we learned those. We know that this stream API replaced the for loop, made our code more readable, and also achieved the chain operation. Those are most commonly features stream advantages stream API provide us. So this is stream API and day 6. So day 6, we learned parallel stream. We know that eternally parallel stream is using fork join pool to speed up the performance. And we learned completable future. Also completable future is used to achieve fully asynchronous, because you know the get method of the future will block the main method. So it's not fully asynchronous if you just use the future. So we use completable future, and completable future defaultly using the fork join pool. And also when you are supply async, it gives you a parameter that you can set, that you can change the eternal thread pool it's using. So also it provides you chain operation. Also, it provides you the way to combine different multiple completable future objects. So this is completable future. Yep, I think basically those are all the things we learned in the for the Java part. And let me check for the first several days of our SQL part. We learned. So see, let me check. This 6. So the day 6 basically are some things. Can everybody see this day 6 document? Can you guys see this one? Like the day 6 document. Like, okay, cool. So you have to be familiar with those SQL queries, because those things can be part of the coding task, right? So those basic syntax you have to be familiar with. And besides those basic syntax, we learned the first day basic some syntax things. And for day 7, also learn what is those syntax and practice some queries based on those syntax, maybe. And for the concept things, we learn transaction, right? This transaction is really important. You have to know what is ACID, like A stands for what, C stands for what, I stands for what, and D stands for what. And also be sure that for isolation levels, you know those 4 isolation levels, and what are the problems with those isolation levels. Like the lowest level rate uncommitted, that has dirty rate, unrepeatable rate, phantom rate problem. And rate committed, it has phantom rate and unrepeatable rate. And the repeatable rate, it has phantom rate problem. And serializable, it does not have any problem because it's using lock. So and also if you have time get familiar with what is phantom rate, what is repeat rate. Like phantom rate is you read some columns that should not exist in your snapshot. Like you insert or delete some rows. And repeatable rate is that if you repeatedly read on some non-repeatable rate, unrepeatable rate means if you repeatedly read on the same rows, it will result in different results. So this is unrepeatable rate on the same rows, and the phantom rate is more like you read some when you read the next time, you select next time, you select some new rows. That is called phantom rate. So it's like a phantom in your table, right? So and yeah, know what is share lock, what is exclusive lock. That's thing for day 7, and for day 8. Day 8. Yesterday we learned index. So you know that B tray and B plus tray, we use B tray and B plus tray for creating index. Those syntax is not important. You can just do not need to remember those syntax. Even for me, I do not remember those syntax. So we just know that we can check the execution plan to tune our database. That is good enough. And you know that we can create index to tune our database, and also also learn the table design. You should know how to design a table based on the different relationship, like if I give you a requirement like one-to-one relationship, one-to-many relationship, or many-to-many. Also, this relationship, you have to judge it by yourself. Like the question will only be like this: you're given a scenario, and you have to decide what relationship this class and student have. You have to determine it, judge it by yourself, and based on the relationship that you come up with, you further design the table. This is what you have to learn. You have to acquire. And you should know what is normalization, like reduce the redundant data, and denormalization, just a reverse operation of normalization, merge multiple table into the same table. Maybe go over this question again to learn how to design tables. Scaling, know what is horizontal scaling, what is vertical scaling. There's a lot of typos, sorry. This should not be a problem. I think it's just sharding. And for day 9, we just today's content. Yeah, you should know that those master slave architecture, sharding, mixed sharding, or different sharding strategies like range shard or hash. Use hash to distribute it. The key value pairs. Oh no, not key value pairs, like the rows, like the data records. And also, this is very important. You should know what is CAPS theorem. And also know MongoDB is CP, Cassandra is AP, and know the consistent hashing algorithm. Maybe read some article about consistent hashing algorithm. But if you have time, just read it. If not, just remember this terminology at least. Consistent hashing. The Redis used for global cache, and also for local cache. Actually, you can use concurrent hash map as the local cache. But yep, and those are some conclusions I give. And those 2 questions quite important. Just get familiar with it. Yep, I think that's it. Yep, that's all for the first 2 weeks training session. And also this will be the last day that I accompany with you guys. For the rest of the training sessions will be conducted by my supervisor. And also the final evaluation is conducted also by my supervisor. So I wish all the good luck to all you guys. Like, wish you guys have good luck in the final evaluation. And also, I think the final evaluation will not be too hard. At least, as long as you go over all the concepts in the first 2 weeks training session, I think is no problem for you guys to pass the final evaluation. It won't be too hard. Just be calm down and easy, and yep, and carefully review all the things we learned. And good luck for everyone. Yep, and that's all for today's training session. And also that's all for the first 2 weeks. if you have questions, you can ask me for now. And if you do not have question, you can feel free to leave the meeting for now. Mhm. Thank you. Thank you, guys.